So this video we're going to talk about the parts of the atom. This should be review, so I'm going to go pretty quick here. You can actually see I have a little cheat here for you, the picture. So we're going to fill in this table to make sure we're all on the same page. Now, two of the particles in an atom, so we got protons, neutrons, and electrons. The protons and the neutrons have a mass, and we say it's 1 AMU for each of them. The electron has a mass, but it's so tiny that we just round it down to 0. Unless you're doing particle physics, we'll just say that it's 0 AMU. Because it's about 2,000 times smaller than the proton or neutron, so it's like 1/2000th of an AMU, so we'll just ignore it. It doesn't really contribute a significant mass to the atom. Now the charge of the proton is positive, the neutron's neutral, and the electron is negative. This should be review, and then here is where they are located. So pause the video, fill out the chart, and actually I forgot to mention at the very beginning, you're going to skip down to this chart. You're going to skip a bunch in your note outline, that's fine. We're going to really quickly go through it in class because we've shortened this unit to make it quicker. So just skip to here and find where we're at and copy this down. We'll move on. So at this point, we will look at the atom like this. You've got the nucleus in the middle, so the nucleus, and obviously the nucleus is really, really small. This is not drawn to scale. If you look at an atom, let's say you were to blow it up to the size of a stadium, like Target Field, let's say that this is the outer edge of Target Field, the electron cloud. The nucleus would be about the size of a pea in center field. So it's really, really small compared to the size of the atom. It's very dense. Now, the protons and neutrons are found in the middle, and that's where all the mass of the atom is, essentially. The electrons are found in the electron cloud out here. And we assume that the electrons, they sit on this ring. So the electrons can be found on this ring or this ring, but they can't be found in the middle here. And we're going to expand on that next chapter. Next chapter is all about electrons. And you probably remember that 2 electrons fit on the first ring, 8 fit on the next ring, and then the third ring is 18 and so forth. So I just wanted to refresh your memory on this is what an atom looks like. Now, how do atoms differ? Well, their atomic number tells you how many protons the atom has. Now, a given element will always have the same number of protons. The protons is what tells you what atom it is. Like carbon has 6 protons. Its atomic number is 6. That's why it's the 6th number or the 6th element on the periodic table. If you have an atom that has more or less than 6 protons, it's not carbon. You can't have carbon unless it has 6 protons. The protons is what identifies it. Now this is found on the periodic table. Again, when you look at the periodic table, the first element is hydrogen. That means it has 1 proton. Second element is helium. That means it has 2 protons. So forth. And it never changes. And here's my example. So when you look at a periodic table, the reason carbon is number 6 on the periodic table is because it has 6 protons. If you have an element with 7 protons, it's not carbon anymore. It would be called nitrogen because nitrogen is the 7th element. Now the mass number. This equals the total number of protons plus neutrons in an atom. And it changes with each isotope. So this is not found on the periodic table. Now you might look at your periodic table and say, well, Mr. Zeta, there's a mass on the periodic table. But I'm going to tell you that that's not the mass number, that's the average atomic mass. We're going to do average atomic mass later, but right now we're just doing mass number, which is just protons plus neutrons. So write down this equation. Mass number equals number of protons plus number of neutrons. It's always going to be a whole number for us. Now if you rearrange that to solve for neutrons, you just subtract subtract protons to the other side, so number of neutrons equals mass number minus number of protons. Okay, an isotope. An isotope is an atom of the same element with different masses. So we find that some elements come, you can say, almost in different flavors. They have slightly different numbers of neutrons. Now the protons is the same, because remember the protons tells you which element it is, but the neutrons is different. So here's our first example, or our example. We've got hydrogen. Hydrogen can be found, it's got one proton. Notice each atom has one proton. That doesn't change, right? If that changed, we wouldn't be looking at hydrogen anymore. They're all hydrogen, so they all have one proton. However, the first hydrogen atom has 0 neutrons. 0 neutrons. That's a terrible N. The next one has 1 neutron, and this has 2 neutrons. So if you look, we write it like this. This is one way to write it, and that's coming up next too. The bottom number is the atomic number, 1. They've all got 1 proton. That doesn't change. However, the mass number is on top. 1 proton, 0 neutrons. 1 plus 0 is 1. 1 plus 1 plus 1 is 2. And then we've got 1 proton and 2 neutrons. 1 plus 2 is 3. So what we know about these 3 atoms, they all have the same number of protons. They're all hydrogen. They're the same element, but they have different masses. They behave the same chemically, but they have different nuclear properties. One is more stable than the other. So chemically they're the same. Now the 2 differences between them is they have a different mass number and they have a different number of neutrons. So if I ask you what an isotope is, you say it's the same element with a different mass, or the same element with a different number of neutrons. Now ions. Ions are the same, are an atom that's basically charged. Now, unless I say otherwise, you'll assume that an atom is neutral, it has 0 charge. If I write a charge on it, then it's called an ion. What this means is that the number of protons does not equal the number of electrons. There's different number of them. We'll assume that they're equal unless I say otherwise. If it's not equal, that means that the atom has either lost or gained electrons. This is super important. An atom becomes charged by losing or gaining electrons. The protons can't change. The protons are buried deep inside the middle of the atom. It's the electrons that come and go. The electrons can leave and be added. They're what give an atom its charge. If an atom loses an electron, it becomes positively charged. If it gains an electron, it becomes negatively charged. Because remember, electrons are negative. We symbolize them E minus because they've got a negative charge. If I lose negatives, that makes me positive. If I gain more negatives, that makes me negative. So here's an example. We got sodium. Sodium likes to lose this electron. If it loses an electron, it now has more positives in the middle than it has negatives on the outside. So it ends up with a positive charge. Because sodium has 11 protons. Right now it has 11 protons, 11 electrons. They cancel each other out. 11 positives cancels out 11 negatives. But if it loses an electron, now it has 10 negatives, but it still has 11 positives. So then we have 1 extra positive. This is why we say it has a +1 charge. Now to be more specific, an ion is anything that has a charge. A cation is specifically anything that has a positive charge. And an anion is anything that has a negative charge. A chemistry teacher once drew this for me. It's a little bit morbid, but it works. You got your little cat here, and then you've got, apparently it's a dead cat, but it works. I've never forgotten it, and students never forget that a cation is positive. I draw a cat with positive eyes. How about instead of thinking that the cat's dead, we'll say it's positive. It's thinking positive, so we got positive eyes there. So cation, positive, that means it's lost electrons. Anion's negative because it's gained extra electrons. I got an example here. We've got sodium. When sodium and chlorine react, the electron ends up transferring over, makes an ionic compound. Now, which atom is positive and which atom is negative? So what's the charge? So pause it, see if you know. So we know that the sodium lost an electron, so it lost the negative. So we know that it's going to end up being positive. Because the chlorine gained an electron, it is now negative. Okay, when we write atoms, and I'm going quick through this because you can always go back and rewatch it if you miss something, or pause it to write it down. There are 3 different ways to write down an atom. I got an example here, uranium-235 with a positive 2 charge. Now, here's one way to do it. You write it like this, and you need to know this structure. You got the symbol, as I obviously have pointed there. You put a hyphen, then you put the mass number. The mass number comes after the hyphen, and then you raise the charge to a subscript. So the charge goes up in the corner up here. That's one way to write it. The same information can be written like this. Here, the mass number, as you can see, is written here. The atomic number is here. Now this wasn't up here, but you don't really need the atomic number. This is a little bit redundant because if you look up uranium on the periodic table, it's number 92. It's always 92. So if I give you the atomic number or the symbol, I'm basically giving you the same information, right? And then the charge would be listed over here. That's why the third way to write it, you can usually just drop the atomic number because, again, it's redundant. If I have a periodic table, I just look up uranium, it's number 92. I don't actually need to write it here, so I don't need it. So that's the third way to write it. So be able to write isotopes in any of these three ways. On a test, you'll see them both ways. In whichever way you choose to write, I'll accept. But just be ready to see both formats and know what the information is. So study this. Obviously here you got symbol, mass number, charge. Otherwise you write it symbol, mass on the top left, charge on the top right. And then sometimes the atomic numbers on the bottom left. I already said that, there we go. So a few handy equations, write these down. I'll let you pause the video and write these down. Now, the top one, the atomic number only equals the number of proton, or the atomic numbers, sorry, I totally goofed that up. The number of protons only equals the number of electrons if the charge is 0. Remember, if the charge is negative, that means you have more electrons. More electrons if it's negative. More protons means it's positive. So I'm going to do a couple examples here. This is how I'm going to end. I got a minute or 2.5 minutes left before I hit my 15-minute limit that I always keep these under. So if I look here, this is my symbol. It's carbon. Carbon is number 6 on the periodic table, so I put a 6 here. This is the mass number. If you go back in the previous slide, remember the mass number, hyphen mass number. So we'll go back. So my mass number is 12. Now the number of protons, the atomic number and the number of protons are always the same. So if I put 6 here, I put 6 here. Now I know that the protons plus neutrons equals mass number. So neutrons plus protons equals mass number. So what plus 6 equals 12? Well, I know 6 plus 6 equals 12, so I know that must have 6 neutrons. I don't see any charge listed up here, so I assume the charge is 0. And if the charge is 0, that means my electrons equals my protons. If I have 6 protons, that means I have an equal number of electrons to balance the charges. Okay, the next one, phosphorus. Phosphorus, if I look it up on the periodic table, it is number 15. That means it also has 15 protons. Its mass number, it's listed right there, it's 31. The charge is listed as -3 right here. Now, what plus 15 equals 31? The answer is 16. 16 plus 15 equals 31. So I know that has 16 neutrons. Now, here's the trick with this one. I've got a -3 charge. That means I have more electrons. How many more? I have 3 more. Okay, so if I have 15 protons, I know that I have 3 more electrons. I have 18 electrons. So always ask yourself, okay, my charge is negative. Do I have more electrons or protons when you're done? More electrons. How many more? 3, -3 charge. That's good. For the last one, I'm going to give you a couple hints here. What plus 54 equals 118? I've got 2 more protons, so that means my charge is going to be +2, and I'm going to let you finish this one because I'm running out of time here. So finish this, bring it to class, do some of them as practice, and we'll go from there.